Hello, today I'll be going over 6.1, which is evaluate nth roots and use rational exponents. So first there are some definitions we kind of have to go over. So if we have the nth root of a to the m power, n is called the index, and the m here is the exponent. Okay, so next is writing radical notation into rational exponents. So radical notation would look like the example above, a to the, or nth root of the a to the m power. So to rewrite this, this would become a to the m over n power. So whatever is here will become the numerator, and whatever was the index or the root will become the denominator. And writing rational exponents to radical notation, so this would be the opposite. Oops, sorry. If we have a to the m over n power, that will become the nth root of a to the m power. So the numerator is the exponent and the denominator is the root or the index. Okay, so in this first section, we're going to rewrite using rational exponents or radical notation. In this first problem, we have the fifth root of 8. So there's no exponent for the 8, but it means there's a 1 there. So whenever you don't see anything as an exponent, that means it's a 1. So this would be 8 to the 1 over 5 power. And just make sure that when you write the exponent, it's a lot smaller so it doesn't look like 8 and a fifth, because these two mean very different things. Okay, next we have a radical. So we want to rewrite this as a rational exponent. So 15 is our base, that's going to stay as our base. 3 is the exponent, so that's going to go on the top, and 8 is the index or the root, so that's going to go in the bottom. So this would be 15 to the 3 over 8 power. Next we have 7 to the 1/3 power, so we want to rewrite this in radical notation. So I'm going to start with this, and 7 is going to go on the inside. 1 is my exponent, so I don't have to write it, and 3 is my root or index, so that goes there. And then the last one, we have 29 to the 9/4 power. So we want to rewrite this with the radical. 21 is going to go on the inside. 9 is the numerator, so that's going to be the exponent. And 4 is the denominator, so that'll be the index or root. Okay, one note though, if you have something like 5 to the 1/2 power, this would be 5, and 1 is the exponent, but we don't write that, and 2 is the root, which would go here, but we don't write that either because this symbol is a square root. So the final answer would just look like that. Okay, next we want to evaluate without a calculator. So for the first one, that just means we're looking for a number that when we multiply it by itself 3 times will equal negative 125, which is going to be negative 5. Okay, number 6, we have negative 243 to the 1/5 power. So that means we're looking for a number that when you multiply it to yourself, or to itself 5 times, it'll get you negative 243. That would be negative 3. Okay, next we have 25 to the negative 3 over 2 power. So if you remember, the negative in the exponent here means that we can move this to the denominator. So this would be 1 over, and I'm just going to rewrite this with square roots. This would be 25. 3 would be the exponent, and then 2 would be the root, so I don't need to write that. The square root of 25 is 5, and then 5 to the 3rd power is 125. So the final answer would be 1 over 125. And for number 8, we have a negative again. So I'm going to move this up to the numerator. So this would be 81, and then we have 3 as our exponent and 4 as our root. So I always do the root part first just to make the number smaller, because if you do 81 to the third power first, you're going to get a really big number, and then figuring out what number times itself 4 times will equal that number is going to be really hard. So the fourth root of 81 would be what number times itself 4 times would equal 81, and that's 3. So I always do this part first, and then I leave the exponent to do in the next step. So 3 to the third power is 27. Okay, next we're going to solve. So for the steps, first you'll want to isolate the part with the exponent. So for this problem, that would be x to the fourth. So I'm going to divide both sides by 3. And I get x to the fourth power equals negative 16. Next, I'm going to use the exponent as an index or as a root, and root both sides. So since this is a fourth power, I would want to use the index or root of 4. So we're looking for a number that when we multiply it by itself 4 times would equal negative 16. Whenever this number here is positive, or sorry, not positive, even, it only works for positive numbers, because a negative times a negative, or a negative times itself by even number will be a positive, and a positive times itself by even number of times would also be a positive. Hopefully that makes sense. So since this is an even number, that means there's no possible way to get negative 16. So this one is actually no solution. Okay, next one. So we're going to start with the same thing. We're going to isolate whatever has the exponent. So that would be this part here. So that means we first have to subtract 36 on both sides. And we get x plus 2 to the 6th power equals 64. Then to get rid of the exponent, I'm going to root both sides with a 6 as my root or index. So then that way it will cancel out with this. So on the left, I would be left with x plus 2. And on the right, I'm looking for a number times itself 6 times that'll equal 64, which is 2. So then to solve for x, I'm going to subtract 2 on both sides, and I get x equals 0. And that would be my final